Picture this. You're in a bustling airport terminal, people rushing to make their gates, pulling suitcases, looking at departure boards. Sometimes it feels like utter pandemonium, a complete free-for-all.
Right.
But then, if you watch for a bit, you might notice little pockets of order, emerging lines forming at the coffee shop, or, distinct streams of people moving in opposite directions down a concourse.
What's fascinating here is that exact transition you're observing. What's the difference between that chaotic mess and those moments where a kind of spontaneous organization seems to appear? Is it just a matter of chance, or are there some deeper principles at play?
That's precisely what we're diving into today. We're looking at this really interesting concept where even in something as seemingly random as a crowd of people, patterns can emerge. Think about it, it's similar in some ways to how a flock of birds can move together in these intricate formations, or even how grains of sand flow.
Yeah.
It turns out that surprisingly simple rules can lead to predictable crowd behavior.
And one of the key things that makes human crowds, well, unique, is that unlike those birds or grains of sand, each person has their own specific destination and a preferred way to get there. This inherent variety, this heterogeneity in our individual goals, is really central to understanding how these crowd dynamics unfold.
Right. So today we're going to really explore this shift from what looks like a completely random jumble of movement to the point where order can spontaneously arise in crowds, even when everyone is heading somewhere different. We want to unpack what kicks off this change and why it actually has real-world significance for us.
Okay, so let's start by picturing those two extremes. Think back to that chaotic airport scene you mentioned. People moving every which way, maybe bumping into each other, no clear lanes or direction to the overall flow.
Yeah, it feels almost directionless, doesn't it? Like if you just looked around, the movement seems the same in every direction. Isotropic, I think, is the term. No real pattern jumping out at you.
Isotropic, exactly. That's a
Yeah.
good way to put it. Movement that looks the same in every direction. No clear flow or pattern.
Yeah.
Now, contrast that with a much more organized situation. You've probably experienced this in a busy but narrower hallway or walkway. You often see these distinct lanes forming, people moving in one direction on one side, and a clear stream of people going the opposite way on the other.
Oh, definitely.
It's like stripes of motion appearing almost out of nowhere.
Absolutely. It's almost intuitive, isn't it? You just naturally tend to fall into one of those lanes, and it definitely feels much more efficient than that initial free-for-all.
And it's important to remember that the physical space itself plays a role in which of these scenarios we're likely to observe. Think about a narrow crosswalk. The limited space pretty much forces people into a back and forth flow, right?
Yeah, it makes sense.
But if that same crosswalk suddenly becomes much wider, allowing people to cross at all sorts of angles, you might see that nice, organized back and forth breakdown into something much more multidirectional and chaotic.
Okay, so here's where it gets really interesting then. We're focusing on that tipping point, when you move from that seemingly random, disordered crowd to the point where some level of organization begins to emerge, even when everyone has their own individual destinations in mind.
And as you mentioned, this isn't usually an instant switch like flipping a light. It's more of a gradual process, and it's heavily influenced by just how much people's intended paths vary, how different their goals are.
So how do researchers even begin to get a handle on something that complex? It sounds like trying to predict the movement of every single person, which seems impossible.
Well, that's where a combination of different approaches comes into play. Researchers build theoretical models using math to describe the basic interactions between individuals.
Okay.
They also create computer simulations, essentially building virtual crowds to see what patterns emerge under different sets of conditions.
Right, like a digital playground for pedestrians.
Kind of, yeah. And then, crucially, they conduct real-world experiments with actual human participants to see if the theories and the simulations actually hold up when faced with real human behavior.
Okay, so we've got these two contrasting pictures of crowd movement, total chaos on one hand, and organized lanes on the other. Now let's dig into why this shift happens in the first place. What are the fundamental forces at play that drive a crowd from one state to the other?
A really fundamental aspect, even when everyone has their own goal, is that people generally try to avoid bumping into each other. It's a pretty instinctive human behavior.
Makes perfect sense. Nobody wants the awkward shoulder bump or the spilled coffee scenario. It's just uncomfortable.
Exactly. And in crowds that aren't too dense, these interactions between pairs of people, just two individuals encountering each other, turn out to be a really key factor in shaping the overall behavior of the crowd.
So it's all about these little one-on-one interactions, not necessarily the whole crowd acting as one.
To a large extent, yes, especially in those less dense scenarios. When two people are on a path that might lead to a collision, even if they're heading in completely different ultimate directions, they'll make small adjustments.
Uh-huh.
They might speed up slightly, slow down a bit, or just take a tiny step to the side to avoid contact.
So it's like a constant, subtle dance of micro adjustments happening all the time within the crowd. Like everyone's doing a little avoidance shuffle.
Precisely.
Yeah.
That's a great way to put it. And one way to simplify thinking about this is the sideways distance between people, that little bit of space to the left or right. Even a small amount of this lateral offset can be enough to trigger those subtle avoidance maneuvers.
Okay, that makes sense. Now, you mentioned earlier that the variety in where people intend to go is a crucial factor. How does that play into this whole transition from disorder to order?
This is where the idea of population heterogeneity comes in. It's really just a way of describing how much the directions people in the crowd are moving in differ from each other.
Okay, heterogeneity, like how diverse the directions are.
Exactly. If almost everyone is going in roughly the same direction, or in exactly opposite directions, like in that hallway example, you're much more likely to see order emerge, like those lanes. But if people are heading off at a really wide range of angles, that spontaneous order becomes much harder to achieve. The system tends towards disorder.
So there's almost a breaking point based on how diverse everyone's intended paths are. Like too much variety and the whole thing just stays messy.
That's the core idea. Theoretical work suggests there's a kind of theoretical threshold for this heterogeneity. If the variation in intended directions goes beyond this threshold, the disordered state becomes more stable, and the emergence of order, like those lanes, becomes less likely.
And how do researchers actually measure this variation in directions? That sounds like a tricky thing to quantify in a real, living crowd.
Well, in their analysis, they often use simplified models.
Yeah.
Imagine two main groups of people, mostly moving in roughly opposite directions, like pedestrians on a sidewalk.
Oh.
Then, the key thing they measure is how much the individuals within each group deviate from that main opposite direction. Think of it like a wiggle room or spread in their intended paths. This spread is a key measure of how varied the directions are overall.
Okay, so if that wiggle room is small, most people in each group are going almost directly opposite each other. You get order, those nice, clear lanes.
Right.
But if that wiggle room increases and people start veering off at more diverse angles, it becomes more of a free-for-all again. Is there like a specific point where this shift actually happens?
Well, interestingly, the research points to a relatively consistent critical angle for this wiggle room or standard deviation in intended directions. The theoretical models suggest this critical standard deviation is around 13 degrees.
13 degrees, that sounds small.
It is quite small. And what's fascinating is that experiments with real human crowds have found a surprisingly similar value, somewhere closer to 16 degrees.
Wow, that's pretty precise. And remarkably close between theory and experiment. So just a relatively small increase in how much people deviate from those main opposite directions, just a few degrees, can be enough to tip the entire crowd from an organized flow into a more chaotic one. That's almost counterintuitive, isn't it?
It really is. That's the power of looking at these underlying rules. It tells us that even though everyone has their own mind, their own destination, a relatively tight alignment in their overall goals is what unlocks efficient movement for the group.
Ah,
And what's even more intriguing is that this critical value, this 13 to 16 degrees, seems to hold up even when researchers use different ways to model how people interact, whether they imagine people as simply bumping into each other like hard spheres or as influencing each other from a bit further away like soft spheres.
okay.
It also seems to be fairly consistent, regardless of the exact shape or pattern of those intended direction distributions, as long as you're looking at that standard deviation, the spread.
So what are the real-world consequences of this shift from order to disorder? Why should we even care if a crowd is neatly organized or a bit more chaotic? Does it really matter?
Oh, it matters quite a bit. This is where it gets really practical for our daily lives. The experiments with human participants have clearly shown that disordered crowds have significantly reduced walking speeds compared to those where lanes form.
How much reduced?
We're talking about a reduction of around 30% in speed.
30%. Wow, that's huge.
It is 30%. That's the difference between making your train on time or missing it,
Yeah.
potentially. It's amazing how these subtle dynamics can have such a practical impact on efficiency.
That's a massive difference. You can immediately see how that would have a huge impact on things like rush hour flow in a busy train station or just trying to navigate a crowded sidewalk. Less order means slower travel for everyone.
Absolutely. And this has direct implications for how we design public spaces, particularly things like crosswalks. There's often an assumption in urban planning that simply making a pedestrian crossing wider will always improve the flow of people.
Which intuitively makes sense, right? More space should mean less congestion and faster movement, give people more room.
Exactly. That's the common thinking.
Yeah.
But what these findings suggest is that widening a crossing might actually lead to a more disordered crowd, especially if it allows for a much wider range of crossing angles, increasing that spread we talked about.
Ah, okay.
And that increased disorder could then counteract the benefit of the extra space by slowing everyone down by that, 30%.
So, in some cases, a wider crosswalk could actually end up being less efficient for moving large numbers of people. That's completely counterintuitive. I would never have guessed that.
It is, isn't it?
Hmm.
And it really highlights the importance of understanding these underlying principles of how crowds behave when we're designing the spaces we move through every day. Maybe narrower is sometimes better, or at least requires more careful thought.
Definitely. Now, we've been talking a lot about these nice, orderly lanes forming when people are mostly going in opposite directions. But what happens in crowds where people have even more diverse intentions heading in all sorts of different ways, not just back and forth? Does that initial order ever fully stabilize?
That's a great and complex question. The research suggests that in truly multidirectional crowds, even if you see some initial formation of temporary local lanes, like little pockets of order, there's a tendency for these lanes to break down over time.
Oh, okay.
This can potentially lead to other interesting phenomena, like people moving in similar directions starting to cluster together, even if they didn't initially intend to.
Yeah.
Sometimes called motility-induced phase separation, but that's getting a bit technical.
So it's not always smooth sailing even after some initial organization might appear. The order can fall apart again.
Not necessarily, no. It can be quite dynamic.
Huh.
However, it's important to note that these later stage effects might be influenced by other factors, like just how dense the crowd is and the physical boundaries of the space they're in, like walls or designated pathways.
Right.
For the kind of everyday pedestrian flows we usually encounter, that initial process of whether those opposing lanes form or don't form because the angular spread is too wide is likely the most significant factor affecting how efficiently people can move.
Okay, that makes sense. You mentioned earlier that the research we're looking at focused on relatively low-density crowds where those pairwise interactions dominate. What happens when things get really packed, like, shoulder to shoulder?
Yeah, that's another really important consideration. In very high-density crowds, you can get into situations of jamming, where people are so close together that any individual movement becomes incredibly restricted.
Right, you're just stuck.
Exactly. And the formation of those orderly lanes becomes practically impossible then. On the flip side, in very, very low-density crowds, people might not encounter each other frequently enough for those clear patterns of order to emerge quickly or even at all.
So there's a sweet spot.
It seems there might be an optimal sweet spot, yeah. That intermediate density, where interactions are frequent enough to drive lane formation, but not so frequent that everything just jams up. That's likely where lane formation is most likely and most effective at improving flow.
So to bring it all together, the way a seemingly chaotic crowd organizes itself isn't random at all. It's heavily influenced by just how varied everyone's intended directions are, that heterogeneity.
Precisely.
And there's a surprisingly small tipping point, this critical angle of wiggle room or standard deviation in those directions, where you transition from a relatively ordered and efficient flow to a much more disordered and, frankly, slower movement.
Exactly. And that critical angle, somewhere around 13 to 16 degrees of spread in those intended directions, seems quite robust and has significant implications for how we think about and design the public spaces we all use if we want to optimize how people move through them efficiently.
It really makes you think, doesn't it? Next time you're in a crowded place, maybe try to pay a little more attention to how people are moving. Can you get a sense of whether that wiggle room, that angular spread in everyone's paths, feels above or below that critical threshold?
Yeah, try and eyeball it.
And what does that tell you about how efficiently everyone is actually getting where they need to go? Is it flowing well, or does it feel kind of sluggish?
And this also raises some fascinating questions about how these principles might apply in other areas where we see crowd behavior. Could similar dynamics be at play in the movement of autonomous vehicles in the future? How do they coordinate?
Oh, interesting point.
Or even in how information flows through complex networks online. And perhaps more seriously, what are the implications for safety in different types of crowd scenarios? depending on whether they tend towards order or disorder. Disorder might not just be inefficient, it could potentially be more dangerous in certain situations.
Yeah, that's a sobering thought. It's truly amazing, though, to consider the hidden order within these complex systems and how research that combines mathematical models, computer simulations, and real-world experiments can uncover these fundamental principles that govern what can often seem like completely random behavior.
Absolutely.
It definitely gives you a new way of looking at the hustle and bustle of everyday life, doesn't it?
It really does. You start seeing the patterns everywhere.